Well, hello again, advanced algebra students. We've come to the end of our week here. So this will be our last video of the week. We're going to look at 14.3, solving triangles. So this is actually probably some of the most practical stuff that we are going to be doing with this trig. And it's basically finding out the missing parts of triangles. And this comes up so much in life because triangles are a part of everything. If you're building and designing things, if you're building any part of like the roof or any angles within a room or something like that, you're always doing this type of trig. If you're in building construction or anything of that nature, it's something that really comes up a lot. So let's go ahead and let's take a look at how we're going to apply trig to solve triangles. So the first thing you have to remember is Pythagorean theorem. So you had this in geometry. So this is just kind of should be a refresher of geometry. And you know that the a squared plus b squared equals c squared, where a and b and c are the parts of a triangle. So if we have a right triangle specifically. So a and b have to be the legs. It doesn't matter what you call a and what you call b. And c has to be the hypotenuse. That part you can't mess up. So first off, when we look at this, let's look at our trig ratios. So if you remember, when we talk about that angle there, theta, this is just a quick refresher. The sine of theta becomes b over c, opposite over hypotenuse. Cosine of theta becomes a over c, adjacent over hypotenuse. And the tangent of theta becomes b over a, opposite over adjacent. So all that should be review. We're just reviewing that for you there, getting it down as review. And now we'll actually start to apply it. So there really isn't any new learning here. It's just a matter of applying what you've already known. So the first kind of problem will give you a point, and they'll ask you to find the trig ratios associated with that point. So the point is in the coordinate plane. So the first thing that you have to do is you have to sketch the location of that point. So notice here's the point that I have sketched there, where notice this is 1, and this distance here is the -5. That goes down 5. So now what it'll ask us to do is it'll ask us to, and I've expanded that triangle so you can see it better. Notice these sides become your A and your B. This side is your C. And now what it wants us to do is it wants us to find the different trig ratios. So in order to do that, I need to know all the sides A, B, and C. So I know what one side is and the other side here. I know two of them, but I don't know C. So I'm going to find C using Pythagorean theorem. So using the Pythagorean theorem, I know that A squared plus B squared, so 1 squared plus -5 squared equals C squared. So going ahead and doing this, notice this is going to become 1, and this is going to be 25. So I get 1 plus 25 equals c squared. So that means that 26 equals c squared. So then c is the square root of 26. So now I've figured out all three sides. I've got a 1, I've got a -5, because it's in the coordinate plane, that side's negative, and I've got radical 26. So now I'm going to go ahead and I'm going to find my trig ratios. So the sine of theta, remember, this is just given as this theta that comes here. It's this angle coming right down here like that. That's the theta we're talking about. Or we could think of it as the angle that starts here and goes all the way around to here. Either way we could think of as being theta. But the sine is going to be the same. It's going to be the opposite side. So if this is my theta, that's -5 over the hypotenuse. So it's going to be -5 over the square root of 26. My cosine of theta will be my adjacent side, which is +1 over my hypotenuse, square root of 26. And my tangent of theta is going to be my opposite side, -5 over 1, which is just -5. And so that's simply finding the three trig ratios that go with that. Now they do want us to find also the three that are the reciprocal trig ratios, the cosecant, the secant, and the cotangent, but those are really easy because remember cosecant's just reciprocal of sine, so just flip that one around. Secant is reciprocal of cosine, flip this one around. And cotangent is reciprocal of this one, so flip that one around. And that's all you have to do, and you've got all 6. Okay, so that's one type of problem you'll have to do. Here's another type. They'll just give you a triangle, and they'll give you the sides of the triangle, and they'll ask you to find, first, they'll ask you to find the sine of A. So if I look at A, I have to pick the opposite side, which is 15, over the hypotenuse, which is 17. So the sine of A would be 15 over 17. The next thing they'll ask you to do is find the secant of A. Okay, the secant of A is the reciprocal of cosine. So you can either do it, you can either think of it as find the cosine first, which is going to be the adjacent 8 over the hypotenuse 17, and then flip it and make it 17 over 8. Or you can just say the secant will be the hypotenuse over the adjacent. Anyway, it's 17 over 8. Finally, for C, it asks for the cotangent of A. So if I look for the cotangent of A, a lot of times it's easiest to find the tangent first. Tangent is opposite 15 over adjacent 8. And then I flip it. So instead of 15 over 8, I have 8 over 15. All right, they also ask for the cosecant of B. So once again, I'm just doing the process. That's the reciprocal of sine. So sine is 8 over 17. So the reciprocal will be 17 over 8. Part E asks for the cosine of B. Cosine of B. Cosine of B is going to be the adjacent 15 over the hypotenuse 17. And finally, well, I guess that's all they ask for is those there. All right, let's look at another one. 15. 15, we now have a missing side of the triangle that we need to solve for. This is where the trig ratios really come in handy, and these are calculator problems. So I know this angle is 55 degrees. I know one side of the triangle, and I need to find this missing side. So the first thing I have to do is figure out which trig ratio to use. Well, in relation to the angle I know, I'm looking for the hypotenuse, and I have the adjacent. So I want the trig ratio that uses adjacent and hypotenuse, which is cosine. So I'm going to set this up as the cosine of 55 degrees equals 24 over x. And so I want to solve for x. So what I'm going to do is I'll multiply both sides by x to get it out of the denominator. So I get x times 55 degrees equals 24. And now I will divide by the cosine of 55. And so I know x is going to be 24 divided by the cosine of 55 degrees. Now I have to go and enter this in your calculator. So you either need to be in degree mode or you need to use the degree symbol when you do this, either one. And when you do that, you get your approximate answer there, 41.843. And you want to look at it and make sure that that looks appropriate. Because if, for instance, if you got something here that was smaller than this, you know it would be wrong because you know that the hypotenuse has to be longer than each of the legs. All right, next type. This is a type where they just give you two sides of the triangle and they want you to find all the other missing sides and angles. So they tell you it's a right triangle and they give you B and C, knowing that C means it's the hypotenuse and B means it's a leg. So I go ahead and I sketch a triangle and I fill in what I know. So I know that one leg is 4.3, doesn't matter which one I call that. And I know that one side is 9.1. That's the hypotenuse, has to be the 9.1. And so I need to find the missing side A, and I need to find the angles alpha and beta. So first let's do the side. To do the side, we'll use Pythagorean theorem. So I know that A squared plus 4.3 squared is equal to 9.1 squared. That's Pythagorean theorem. Now I will subtract this 4.3 squared. So I know that A squared is equal to 9.1 squared minus 4.3 squared. And then I will take the square root of A, or take the square root of this. So I know A is equal to the square root of this. Now I can just enter all this in my calculator. And I get that's approximately 8.020 when I enter that in my calculator. Okay, so now I've got my sides figured out, but I need these two angles. Well, really, all you have to do is get one, and then because this is 90, you know you can just simply take 90 minus the angle you've got for the other one. So let's go ahead and let's find out one angle. So we're going to start with what I want to do, since this is not exact, and we are giving these exact here, we want to use these two sides. So I could either go for beta and use opposite over hypotenuse, in other words, sine of beta, or I can use alpha and use adjacent over hypotenuse. I'm going to use alpha. So I'm going to solve for alpha here. I know that the cosine of alpha, since we've got adjacent over hypotenuse, I know the cosine of alpha is going to equal the 4.3 over the 9.1. But remember, I want the alpha. So what I'm going to have to do is, this is where your inverse trig comes, because I want to know the angle that goes with this ratio. So I switch this up, and I know alpha is equal to the inverse cosine of this ratio here. So now this is just plugging into your calculator. You do need to be careful when you plug into your calculator on this, because as I go ahead and do this here, so I want the inverse cosine, so I hit my trig and I keep going until I get inverse cosine, and I got 4.3 divided by 9.1, but my calculator, notice, is in radians. So either I have to change it to degrees, or I have to make sure that I'm asking for the answer in degrees. The way that I ask for degrees, even though it's in radians, is I go to my catalog and I pick that arrow DD, and that tells me I want my answer in decimal degrees. So if I go ahead and hit that, I get that my answer is 61.802. So my answer becomes 61.802 degrees. Okay, and then to get beta, I know that beta is just going to be 90 minus alpha, and I can get beta. So your homework is 14.3, and it's 8 through 24 even. Okay, hope that goes well. We will. This is it for the week. And next week we will finish up with chapter 14, which will finish up with everything, and then we will prepare for the test. All right, we'll talk to you later. Next week we'll start in and finish up 14.